Dear students, in the previous class we have seen what is a software architecture and what is the difference between software architecture and software design. And software architecture, it deals with the bigger structures and it deals with how multiple software processes cooperate to carry out their task. Already we know that architecture means it is a complex structure. It is a combination of multiple components where each component plays its unique role. And design refers to the smaller structure and it deals with only one component and behavior of that particular component. And also how we can define a software architecture with the different components. Software architecture, it deals with quality attributes, it deals with the IT environment, human dynamics, business strategy and design. Quality attributes are nothing but again the attributes of good software. The software should be manageable, it should be portable, it should be secure and robust, dynamic, scalable. These are the different qualities of good software. Along with this, the software architecture also contains the IT environment. IT environment, what is the type of IT environment it should contain? Okay, what are all the facilities it must when we launch the software, what the facilities should the IT environment contain? These are comes under the IT environment. And next, human dynamics, what is the role of person? The team of workers, the team of people that are writing they develop a code and implement and design and launch into the market, testings. These all categories of people, testers. These all categories of people comes under the human dynamics. What is the role of human? And business strategy, many types of business strategies we need to implement in order to develop a software architecture. And next is design. Design, many design patterns are available. Okay, many design patterns are available and which kind of design are suitable for what type of software that need to be considered. This is about how the software architecture deals with the different components and their relationship and how they interact with each other. And we focus more on software architecture. It acts as a blueprint for a system. Without a software architecture, we cannot move further. The different types of complex components and different types of structure together form a software architecture. In order to plan the system in an easier way, in a simple way, we have to generate a blueprint of a system. So software architecture, it acts as a blueprint and it defines a structured solution to meet all technical and operational requirements. Structured solution means how the structure should be, which are all the components should be added, whether it is the programs or libraries or interfaces or operating system, which are all to be added in order to meet the technical and operational requirements. Yesterday we have discussed what is the technical requirement and the operational requirement, and these requirements are very essential in order to optimize the quality attributes like performance and security. Also, this software architecture is a phenomenon. It helps to make different significant decisions about the organization related to software development, and each of these decisions can have considerable impact on quality, maintainability, performance and overall success of the final product. And these decisions contains these following aspects: the selection of structural elements and their interfaces by which the system is composed. Okay, and next, behavior has specified in collaborations among those elements, and the composition of these structural and behavioral elements into a large subsystem. Architectural decisions align with the business objectives. Architectural styles guide the organization. Okay, just see this picture. In this picture, we have different components that constitute a software architecture, and how they interact with each other, how they communicate and cooperate to achieve a particular task. This is about to do this we have to make a certain decisions, and these decisions are as follows. These are the four major decisions before developing any software we need to take. That is selection of structural elements as well as interfaces, and behavior has a specified in collaboration among those elements, how they behave. First we will select the elements and how they behave each other, and next composition of these structures, and behavioral elements into a larger subsystem, and architectural decisions align with the business objectives. Okay, for this I will tell you the one analogy. Our human body is a one structure, it is architecture. Here different parts are interact with each other. If you consider the heart it purifies the blood and circulate to different areas of the body. And how it circulate to different areas of body, it is a one challenge. And how the different parts of the body interact with the heart. So here heart is a one element, and the heart circulates blood to brain, and different organs, kidneys, liver, different organs of the body. Imagine these are the different components of the body architecture, and how they interact and how they communicate. This is a collaboration. This is a behavior specified as a collaboration. Here selection of structural elements means here I need to select in order to develop one robot like a human body. I need to first develop one heart and different organs, and all the organs has to communicate each other. This is a selection of structural elements, and behavior, how they behave mutually and individually. This is another important task. And finally I need to decide whatever the robot I have designed, what is the final output of this, what is the business objective of developing that robot. And to develop that particular robot, I need to select a particular architecture style to guide the organization. This is how the software architecture behaves. This is one element X, this is element Y, this is element Z, and this is element A, and this is element B, or this is element C. And putting all these different kinds of elements and different sizes of elements into a one platform, again it is a one big task. And what is the individual role of these elements, and how they behave each other, and how they behave mutually interacting with each other. Okay, this is one architecture. In a software also, we need to consider different kinds of software components, and we have to check the behavior of the elements. And to design this, first I have to design a one architecture style. Means I need to choose one architectural style. And afterwards, what is the final business objective of this architecture? Okay. And next we will focus on what is the software design And software design provides a design plan that describes the elements of the system, how they fit and work together to fulfill the requirement of the system. And the objective of having the design plan are as follows. In order to negotiate, means in order to arrange the system requirements and to set expectation with the customers, marketing and management personnel. Okay, this is one design plan. First we have to arrange the whatever the requirements are needed to design a system, and set the customer expectations, and marketing personnel and management personnel. These three people are called as a stakeholders of a software. And next, this software design, whatever the software design format, this phase, this acts as a blueprint during the development process, and guide the implementation task, including detailed design, coding, integration and testing. In this picture you can see this is a software architecture design. It contains, it interacts with three different components, or you can say elements. The first element is domain analysis, requirement analysis, risk analysis, and another element is hardware architecture design, and another element is detailed design, coding, integration and testing. The software architecture design has to interact with these domain by considering the aspect of requirement, desired quality. And next, if there is any risk, if any alteration is required, in that case they have to make a modification to the requirement. If any fault is there or a loophole, any drawback, if the designed software product is failed during the testing, then we have to remodify the product. This is a software architecture design, how it interact with different domain analysis and requirement analysis as well as risk analysis. Next, in the same way, the software architecture design interacts with the hardware architecture design using its own procedure, and if hardware modification is also needed, that will be informed to the hardware architect. And finally, we come to the implementation. After modifying and remodifying the required kind of quality, when we reach the final desired product, then we can go through the implementation constraint, and it mainly deals with the detailed design, coding, integration and testing. This is about software design. And finally, after going through all these aspects, we can make out the list of goals of architecture. The primary goal of architecture is to identify requirements that affect the structure of the application, and apart from this, some other goals are as follows: expose the structure of the system but hide its implementation details. Because suppose I want to develop one software, and without hiding the implementation, I developed it and launched it in the market. Under third party, the company can copy the details how I implemented that software, and some modifications they can do, and implement and launch it in the market as their own product. So being an architect, I need to take care of that is how to hide the implementation details. Okay, we can expose the structure of the system, but we need to hide the implementation details, and realize all user cases and scenarios. Okay, how the use case diagram, how the users are interacting with each other, from architect to the end user. In between, we have developer, tester, stakeholders, etc. Many people are interacting in the use cases. How